name is Chelsea Thompson. I am a research scientist and science communicator at the NOAA Chemical Sciences Laboratory, and I am a contractor for the University of Colorado working at NOAA in support of NOAA's mission. The NOAA Chemical Sciences Laboratory is a research laboratory that studies the chemistry and the composition of the atmosphere. The atmosphere is broken down into multiple layers. The ones that we are most interested in, though, at CSL are the two layers that are the closest to the ground. So the first one, right near the surface, which is the air that we breathe, we call that the troposphere. And then right above that is the stratosphere. And the stratosphere is where the ozone layer is, for example, and often where your commercial aircraft would fly. And these are the two layers that really are the most important when we consider air quality, how that affects our health, and also climate. So to do our research, we have a lot of tools that we use. The three most common are measurements, modeling, and laboratory studies. And so for doing our measurements, what we're really doing is making observations of the air and of the atmosphere. And what we use to do those measurements frequently are research aircraft. And that's because using these research aircraft, we can actually fly through the sample that we are trying to measure, which is not very common in chemistry, but we get to do that in atmospheric sciences. And then we can measure from the aircraft what is in the air at all different altitudes. And so the aircraft that we use to do our research vary depending on what we are looking at, how high we want to go, and how many instruments that we want to carry. When we're talking about air quality, for example, and what's in a city, we're going to be using a really large aircraft that we can fill with all sorts of different instruments that can measure a variety of pollutants that is being emitted by a city. So that takes a lot of very specialized instruments and a very large aircraft to do that. When we're getting up into the very high altitudes, up into the stratosphere, we are limited because all those aircraft are very small. And there's also no emissions. Well, there's not a lot of emissions specifically in the stratosphere like we have near the surface. A lot of the pollutants that we're interested in are emitted at the surface by people or by cities, for example. So some of the aircraft that we use come from NOAA, from the Aircraft Operations Center in Lakeland, Florida. And there we have a fleet of P3 Orions, which are actually the Hurricane Hunter aircraft. So if you've seen during the hurricane season, the aircraft that fly straight into the storm and go into the eye wall, these are the NOAA P3 airplanes. And so when they're not flying in hurricanes, we will use those to do atmospheric research and fill them up with our instrumentation. We also have smaller aircraft called Twin Otters. Those are also NOAA aircraft. They are small turboprop airplanes. They fly pretty low and pretty slow, and we can use those to really get into like low surface areas, like near a city, for example. And then we also often will use NASA aircrafts. And so the NASA aircrafts are the ones that right now are the only ones that can reach the stratosphere and stay up in the stratosphere for an extended period of time. And so we collaborate often with NASA to use their planes. The DC-8, it's actually our largest airborne science laboratory. This is a converted commercial jetliner that is actually from the 70s. It used to be an airplane for Alitalia back in the 70s. And since that time, NASA purchased that aircraft and modified it heavily for atmospheric research, ripped out all the seats, put in a big mission control center and such. And so we are able to fill that to the brim with a lot of instrumentations. And that's a really powerful aircraft as well because it has a very long range. And so we're able to reach remote regions or fly over the oceans for a long period of time with that aircraft. We have these large instruments that we put into metal racks, and those racks are then bolted to the floor. So we have to make sure that everything is very, very secure for takeoff, for landing, for turbulence, for example. And so everything is bolted very, very securely to the floor. And so if you can imagine now looking down the center of an aircraft, we just have these racks of instruments going down the tube of the aircraft. And then behind each rack, we'll have a seat or potentially two seats for the scientists to sit in front of their instrument while they're flying, and then they can operate their instrument and look at their computer screen and see in real time what their measurement is of their particular pollutant. For example, like ozone is one of the things that I used to measure quite frequently on these aircraft. And so I would watch on my computer screen as we're flying along what ozone is looking like in the atmosphere. And so to actually do the measurements of the air, what we've done is removed all of the windows, and then we replaced those with a metal window plate that has what we call a probe or an inlet that is sticking out. It's basically a metal tube that sticks out of the window plate into the air. And so the entire time we're flying, we're pulling this air in through the window inlet into the instrument and measuring all of the species that we're interested in. Most of the time, we're not actually collecting any of the air. We're just measuring it and then pushing it right back out. So all of our instruments have these exhaust lines that go all the way to the back of the aircraft, and then there's outlets in the back. And so all of the air is pulled in through the windows, goes into the instruments, and then back out the end of the aircraft. One of the things that people ask me a lot is what it's like to fly in these research aircraft. And they're really quite different than your standard experience on a commercial aircraft. Those commercial aircrafts have really been designed for passenger comfort. The DC-8 aircraft, which used to be a commercial airplane, and it is now in its research state, it is very, very loud. So when we're flying, we always have to wear these big noise canceling headphones because the engine noise is just deafening. They're also often very hot, and so most people are sweating. They're very uncomfortable. And then on top of the heat, it's often very, very, very bumpy. Maybe an 8-hour flight will be sort of bouncing around near the ground. And so that's really quite uncomfortable. Even though it can be a little difficult to fly on these research aircraft or a little uncomfortable, it's still really the coolest job. And this is why I love this job, is that you're just doing something that nobody else really has the opportunity to do. And you're flying in these very interesting government or military aircraft. And oftentimes you're flying sometimes all over the world and seeing different places as you go. One of the projects that I was on just recently was the NASA atmospheric tomography mission. And in this particular project, we actually flew around the entire Earth 4 different times in 4 different seasons. And so we took the aircraft from California, where it's hangared. We went up to the Arctic, to Alaska, and then down the Pacific to Hawaii, Fiji, New Zealand. We cut across to the very southern tip of Chile and flew around Antarctica for a bit. And then we went back up the Atlantic, Ascension Island, Azores, Greenland, and then back to California. And it was just the most incredible trip. It was very tiring, as you can imagine. These flights are 9 to 10 to 11 hours apiece. And each time you're in a different time zone, you're in a different place, you have to land somewhere new, figure out how to get to your hotel room, get food, and get some sleep, and then do it all again the next day. So if it's summer in the northern hemisphere, it is now winter in the southern hemisphere. And so you have to pack for both of those seasons simultaneously on an aircraft where we are very limited to weight, right? So there is a certain weight that an aircraft can be to take off from the ground. And we are filling that aircraft with instruments, and we're filling it with people, and we're filling it with fuel so that we can make these long flights. And there's not a whole lot of room left over for baggage. And so we had about 42 people on the airplane, and we were all limited to 2 very small 25-liter duffel bags that I got to go to places that I had never been. I'd only, read about or seen about on TV. And just the cultural experience of going to these different places was very exciting. And then you also went to places that most people will never go to. For example, Ascension Island is this bizarre little island in the South Atlantic that's off the coast of West Africa. Um, they actually call it the Rock. When we got off the aircraft, they said, "Welcome to the Rock." It is a military base. It's a joint U.S. British military base. And so if you don't have a military reason to be there, then most people are never going to go there. And so that was just a really amazing experience to be able to see that very strange little island in the middle of the ocean.